Hello everyone, it's Benny, and in this video, we actually are going to start generating our mesh. So first off, I'm going to take this data that we have right now and comment it out, because we don't want to use some pre-entered mesh data, we want to actually generate the mesh data from our level. So, the way I'm going to do this is I'm going to use an array list of vertex called vertices. It's a new array list of vertex called, well, no, not called anything, just new array list. And we need to import array list. And the idea here is the exact same thing I did with the mesh loading system. So this way, I don't know, well, first off, this needs to be integer. The idea is I don't know how many indices or vertices I'm going to have, so I'm just going to put them in array lists. Then I'm going to generate the mesh by just putting in whatever vertices and indices I need into here. And at the end, well, I'm going to generate the arrays, the appropriate arrays. And yeah, so I'm going to have a vertex array called vertarray, and that's going to equal, well, nothing yet, is it? Well, no, it's going to equal a new vertex array of size, vertices dot size. And I'm going to have the same thing for integer array. So integer array called intarray equals new integer array of indices dot size. And I'm just going to put, well, all my finalized data in there. So vertices dot toArray is going to take in vertarray. So it's going to save it there. And indices dot toArray intarray. So now we have all our data, now we just need to put it in. Vertarray can be put straight in. Indices, we need to convert that to integer, so I'm going to use util.toIntarray with intarray. And with that, we should be pretty much good to go with actually generating the mesh. So, what I'm going to do is I'm going to copy this double for loop, and I'm going to sort of repurpose it to be a level generation loop. But before I actually generate levels, I'm going to need three constants. One for how wide one square is going to be, one for how long the square is going to be, and one for how high a square is going to be. So, you know, basically dimensions, because I'm supposed to be generating cubes from this. So what are the dimensions of the cube? So I'm going to create three constants. Private static final int. This one is going to be called spot width, which I'm just going to set equal to 1. Actually, it should be a float. So spot width, spot length, and spot height. So just the constants for the dimensions of the cube. Right now I'm just going to do 1, 1, 1, and later on I can change that if I really want to. But anyways, let's go to our loop. Now the first thing I want to do is I want to create, well, I want to create the floor. So that way I have a nice visual indicator of where the floor is. And I'm going to start by, well, I'm going to start by just adding vertices. So add new vertex, going to be nothing with, with new vector 3f with nothing, and a new vector 2f with nothing. And one more. Okay, there we go. And I'm just going to add 4 of these, because I'm going to need 4 vertices for the floor. Now, the first thing I want to tackle here is actually the texture coordinates, because eventually I'm going to need to be able to sort of generate texture coordinates so that I can get texturing to work properly. So what I'm going to do is I'm going to have 4 variables, float x lower, well, I'll start x higher, why not? Actually, I'll start capitalized, why not? Equals 0. And again, I'm just going to assign it to 0 for now. I'll figure out the values later. So x higher, x lower, y higher, and y lower. So, predictably enough, these will be the texture coordinates. The one for when it's at the higher end, when it's like going outwards, because I'm sort of drawing outwards from the point. Like, you know how I normally would do texture coordinates? I'd do something like 0, 1, 1, 1, 1, 0. It's sort of like this, except I replace zeros with the lower and ones with the higher, because they'll be the lower and higher coordinates respectively. So yeah. Now to actually get the values of these, well, I don't know what there are yet, so I'm just going to set the higher ones to 1 and lower ones to 0. And then I'm just going to sort of fill in, I guess. So that just leaves the question of how do I actually fill these in? And for the time being, I'm just going to go for what I had right there. So start with x lower, and again, x lower, and here again, well no, that should be higher, so I'm going to leave that as it is. And finally, again, x lower. Wait, I did that wrong. This should be y lower, because that's, you know, the y coordinate. So there we go. This should be y higher, x higher. So you see, I'm just putting higher where I'd normally have 1. So in hindsight, maybe I would have been better to do 1, but I like this better. I think it's more descriptive. So with that gets the texture coordinates. Now all we have to do is figure out how do we actually generate the proper, well, positions here. And in order to actually get the vertex coordinates, what I'm going to want to do is I'm going to want to use the I and j values. So the way this is done is actually pretty simple. I want I times spot width, because that's sort of the x component. I don't want anything on y, because it's a floor. It's not going to move on the y. It's all going to be in the xz plane. So here I'm going to do j times spot length. And there you go. And I'm going to just start off with that on everything. So maybe I should have done this before I copied, but oh well. I'm going to space that out because that's going to bother me. Okay. So how do I do this? Well, I actually want to draw clockwise, so ooh. Well, actually, I'm going to need to change my coordinates around a little bit, because otherwise I'm going to have a drawing order issue where the floor is actually going to be displayed inverted. Well, it could be fixed easily, it's just whatever. I'll do it like this, and no, I'll do it the way I know it works. So this actually needs to be reversed. I need to reverse these two because of my drawing order. So, and you'll see when I actually start doing it. So, and y higher. So I just reversed this one and this one. Why? Because this I'm going to start with x plus 1. So 1 more than whatever my position is, times spot width. So I'm drawing, think of it like, if this is my square, I'm starting at this corner and drawing to this corner. And that's sort of why I'm doing it, because this way, my x higher is sort of matching that. I have the appropriate texture coordinate for that, so yeah. Because, you see, the x is getting the higher point at this one now, too. So there you go. And now I'm going to do sort of the same thing here, so I plus 1 times spot width, and j plus 1 times spot length. And finally, I'm just going to end off with j plus 1 times spot length. So same sort of procedure. I'm starting with this one, then this corner, and then this corner. And yeah. So now all we have to do is actually create the faces. And I'll actually put a little comment here so we know this is the generating the floor part. And the easiest way to do that is just to say indices.add, starting at vertices.size, and then add whatever the appropriate coordinate is. I found that's the easiest way to sort of do this. So I'm going to start at 2, and come on, there we go, and 1 and 0. So I'm essentially just doing this, and this. The reason I'm doing it like that is because that's a clockwise order, so it should be facing up. And then I'm going to do 3, 2, and 0. So that should give me this, and this. And the reason I'm doing it like that, again, it's a clockwise order. So with that should, keyword should, generate the floor. So if I run, well, oh my. Well, it's generating a floor everywhere. which is good. That's what it should be doing. The thing is, though, well, I don't want floor everywhere. I only want floor where my level actually is. Or do I? Yes, I do. What am I saying? So, what I actually want to do is first off, I want to do... I know how I'm going to do this. Okay. Here's what I'm going to do. I'm going to do a simple condition check. If level.getPixel sub I comma j, so that gets me... What's wrong with this if statement? Okay, so if that pixel, and here's what I want to do. If this pixel, I comma j, and I want to actually do a bit mask, and 0xFFFFFF. Why? Because this will just give me the RGB component, because you notice I'm only doing a 24-bit of ones. So what that means is I'll only have the RGB components, the alpha component will be just chopped off. So what I want to do is I want to test if the RGB component of this whole thing, so I'm actually going to put this in parentheses because bitwise operations have a weird evaluation order, if this is equal to 0. And what's that going to tell me? If it's a wall. If it is a wall, then just continue. We don't want to do any of this. We're not going to need... Well, we may eventually need to do anything, but right now we don't need to do anything. So now if I run, then, hey, look at this. We have a giant... Yeah, we have our floor sort of mapped to what our image was. Granted, I don't think this is exactly the way our image looked. In fact, I'm probably going to bring it up to compare in just a moment, but yeah. The point is, right now, we have a level that's being generated based on what our image is, what we've painted in some program. So yeah. And one moment, I'm going to bring it up and make sure everything's appearing correctly. Okay, I got the image open, and now if I run, and back up, we can see the level. Alright, that's great. Here's the image. So, it is indeed generating something in the shape of the image, but the issue is, it looks just a little bit flipped. So, in order to remedy this, I'm going to need to flip the whole image on the x-axis. So that way, well, we get the level generated in the proper orientation. So, the way I'm going to do this is I'm going to go to the bitmap class, and I'm going to create a new method that I'm going to call, it'll be public bitmap flipx. And it's going to flip the entire bitmap on the x-axis. So what I'm going to do is I'm going to have an int array called temp. It's going to equal a new int array of pixels.length. And here's what I'm going to do. I'm going to go through every single pixel in the bitmap. So I equals 0, I is less than pixels.width. Right, I already have variables for that, so. And then for int j equals 0, j is less than height. And here, all I have to do is perform a basic flip. So I plus temp sub I plus j times width. Because remember, that's how we access the bitmap, like we do here. This is going to equal, and we have to be very careful in how we access this. Now, normally what we do is we do I plus j times width, but that's just going to be the identity. It's not going to fix anything. Oh, and of course, here we have to do pixels equals temp, and then return this. So right now this doesn't do anything, so what we're going to do is we're going to sort of flip our x-coordinate. We're going to start at width minus I minus 1. And what this is going to do, width minus I, that's going to do the actual flip, and minus 1, so that if I do something like, for example, I is 0, I don't get width and then get out of bounds and weird pixel things. So this should flip it on the x-axis. Are there more efficient ways to solve the problem? Yeah, probably. I'm just doing this because it's easy. So we might want to put a note of that. Just, again, have some way of better texture. So I'll say texture manipulation. We already sort of have this as better textures. Texture manipulation, such as translation, rotation, scale. There we go. And with that, what I'm going to do is when I actually load it, first off I'm going to get rid of this, or comment it out at least, because I really don't care anymore. I'm going to set this to bitmap_flipx. And with that, I should be able to run. And if I look now, I flipped on the wrong axis, didn't I? Let's open the image. Yep, I've flipped. Well, it's almost right. I'm just flipping on the complete wrong axis. So, yeah. Let's try this again. I'm going to go to my bitmap. And what I'm going to do here is I'm going to change this. I'm going to keep I the same. I'm going to change this to flip Y. Well, actually, you know what? Why not? I'll keep both. It's a temporary class anyways. So I'm going to have flip Y now. And Y is going to do almost the same thing, except here it's going to do J, well, height minus J minus 1. And that should flip on the y-axis. And don't run yet because I am not using the method, so change this to flip y. And if I back up, then I don't know about you, but the level looks almost correct to me. So if I open this, hey look, we got the level in the proper orientation. So there you go. Our level's working. It's generating the floor, at least the floor. I mean, we still got to generate the rest of the level. That's going to be an issue in and of itself, but we've got the floor working. We can fly around the level. We can do things, but it's not much, just a floor. So yeah. Alright, so now that we got floors working properly and everything, let's go ahead and let's generate ceilings. So I'm going to go ahead and generate ceiling. And this is going to do almost exactly the same thing. Almost. With two key differences. The first being, 1, spot height. We're not going to be generating this at floor level, we're going to be generating this at the maximum height. And difference 2, we need to reverse our texture coordinates. Why? Because the way we have it like this will draw something facing up. We want to see our ceiling facing down. So now, I should be able to run and have this nice sort of, it almost looks like an invisible maze in a sense, but yeah, we've got floors, we got ceilings, and everything's nice. But now we've got the challenge of walls. And walls, well, they're a little bit trickier. So, I'm just going to start very simple by having a comment. Generate walls. Now, generating the walls all starts with this line of code right here. The one that checks if the pixel is blank, some wall. Why? Well, we already know that this pixel that we're generating stuff for isn't a wall, but what we want to check is if the adjacent pixels are walls. So if I-1 or J-1 or etc. is a wall. And the way this is going to work is if it is a wall, then we're going to generate sort of this wall image there. And if it's not a wall, then, well, we're not going to do anything. So, yeah. And that's the way our wall generation is going to work. So what I'm going to do is I'm going to just copy the ceiling code, because we want sort of the same thing. And now we come across a more interesting issue. Right now this is generating a sort of a ceiling in the XZ plane. So it's basically just something in the XZ plane, but we don't want something in the XZ plane. We want this in the XY plane. So the way I'm going to do this is I'm just going to change the code, and then I'm going to sort of show you why it works after I'm done. So I'm going to get rid of the J+1, everything's in J. Then I'm going to change the spot heights, these first two to 0. And that's going to generate the appropriate wall. Why? Here's the thing. Walls are in the XY plane. They go up and horizontally. At least these do, because I'm checking pixels in the, the Z plane. Because it's in the Z plane, the wall needs to be in the XY plane, if that makes any sense. Bleh. That doesn't make any sense. What am I even saying? Okay, I'm checking if there's some wall behind it. if the wall is behind it, then the wall needs to be in the X because it needs to be sort of perpendicular to the way we're checking. It would make sense if there's a pixel behind it, so I'm going to build this wall next to the hole. No, I want to cover up the hole. So, there we go. That's why I'm doing it in the XY plane, not the ZY plane. And what I'm doing here, that's also why the Z plane is constant, because, well, I do want it at the appropriate position, but I don't need to do anything fancy. It just needs to be at the appropriate Z position, nothing more, nothing less. Kind of like the way in my floor and ceiling, I set Y to some constant, whether it be 0 or a spot height, so it's in the appropriate position, but it doesn't affect how it's actually generated. It doesn't affect the... well, you get the idea. Now, the actual generation is done on the X and Y plane. Now, for X, this is exactly the same. It goes start, high, even low, high, high, low. A, B, B, A. Same sort of pattern. But the difference is, rather than it going up in the Z-axis, it's going up in the Y-axis, like right here. So there you go. That's sort of the way the wall generation works. And if I run, it might look like nothing's happening, but if I go back, you'll see, well, we get a whole bunch of walls generated in the appropriate positions. So there we go. That's the sort of basis of how our wall generation works. So, now I'm going to check the wall facing the other direction. The one where it's sort of facing J plus 1. The one, if there's a wall up. Now first off, like before, I need to reverse the texture coordinates. So, because I don't want to generate a wall that's facing away, I want it facing towards. So, that does that. And the way you change this is actually pretty easy. It's just change J to J plus 1. Because I just want it at a difference in the Z-axis. Kind of like the same way I did the floor and ceiling. So now if I run, you'll notice it's starting to be a little bit more comprehensible. I'm getting actual kind of hallways going on here. So now I've got all the walls on the Z-axis properly generated. What about the walls on the X-axis? Now that's still a problem. So now I'm going to generate on the other two. So I'll start with this one. Well, actually, I already have that copied, so I'll just paste. Oh, I don't have that copied. Never mind. So, now that I have that copied, I'm going to get rid of the J check. Don't need to worry about that. I minus 1. First off, it's going to be constant on the I plane, so nothing to worry about there. And as for J, it's going to do the AB position. So essentially I'm just reversing I and J here. And actually, I think I need to reverse it here. I think this is actually... I actually do think this is going to be reversed. If not, I'll change it back, but I think this will need to be reversed. So let's run, and... yes. So now I've got walls there. I've actually got most of the walls set up now. If I look at it this way, the level looks absolutely fine. I'm only missing the walls on that way, so just do the exact sort of same process I did before. I plus 1. If that's the case, reverse it, so 0, 2, 0, 3. And here, I'm just going to check I plus 1 instead. So, again, it's the same ceiling floor phenomenon. I'm moving it on the axis, so it's in appropriate position, and just reversing the coordinates so it's facing inwards. And with that, although it may be kind of painful with our ridiculous checkerboard pattern, we do indeed have proper level generation going on. So, yeah, we now have our level generating a 3D world based on all the information we provided it. So there we go. And with that, that concludes level generation. We've taken a bitmap image, and we've generated a big, explorable 3D world out of it. So yeah, hope you enjoyed, hope you learned, and in the next video, well, I'll see. Maybe I'll start working on texturing, because this is getting a little bit... yeah, our test texture is just a little bit painful to look at. So yeah, hope you enjoyed, hope you learned, and see you next time.